Language of chemistry. Chemical reactions. By now, we are familiar with the term chemical change. When a chemical change takes place, it is irreversible. The substances taking part in the change, reactants, are different from the substances produced, product. The properties of the reactants and products are different. A chemical change is often accompanied by the release or absorption of energy. In a chemical change, the atoms that make up the molecule of the reactants react with each other to produce molecules with a different arrangement of atoms, and this is the reason why the chemical change is irreversible. Thus, we may sum up that chemical reactions occur when two or more molecules interact and the molecules change. Bonds between atoms are broken and created to form new molecules. Chemical reactions involve transfer of energy. In the previous lesson, you have already learned that atoms are made up of subatomic particles called protons, neutrons, and electrons. These subatomic particles are held inside the atom due to energy associated with them. So, when a chemical reaction takes place, there is transfer of energy, and while some chemical bonds are broken, some new bonds are formed. In a chemical reaction, you start with one molecule and turn it into another. Chemical bonds are made or broken in order to create a new molecule. An example of a chemical reaction is the rusting of iron. This rusting happens because the iron, Fe metal, combines with oxygen, O2, in the atmosphere. Chemical bonds are created and destroyed to finally make iron oxide, Fe2O3. Iron plus oxygen from the air gives iron oxide, rust. A reaction can include atoms, ions, compounds, or molecules of a single element. You need to remember that a chemical reaction can happen with anything, just as long as a chemical change occurs. If you put pure hydrogen gas, H2, and pure oxygen gas in a room, they might be involved in a reaction to form water, H2O. However, it will be in very small amounts. If you were to add a spark, those gases would be involved in a violent chemical reaction that would result in a huge explosion, exothermic. Hydrogen gas plus oxygen gas gives water, gas, or liquid. Another chemical reaction might include silver ions, Ag+. If you mix a solution with silver ions with a solution that has chloride, Cl- ions, silver chloride, AgCl precipitate, will form and drop out of solution as a precipitate. You can observe this as a reaction between silver nitrate and sodium chloride, common salt. Silver nitrate solution plus sodium chloride solid gives silver chloride precipitate plus sodium nitrate solution. Fact: chemical reaction is different from physical change. When you melt an ice cube, it is a physical change. No new molecules are created, no chemical bonds are broken or made. The heat is absorbed by the molecules of ice and it is changed into water. When this heat is removed by cooling the water, it freezes to make ice. Factors affecting rate of chemical reactions. Chemicals are always combining or breaking down. The reactions happen over and over, but not always at the same speed. A few things affect the overall speed of the reaction. For example, you may have noticed that making of curd from milk takes a longer time in cold winter months as compared to warm summer months. Do you know? Some reactions take hundreds, maybe even thousands of years, while others can happen in less than 1 second. If you want to think of a very slow reaction, think about how long it takes plants and ancient fish to become fossils. Carbonization. Temperature. When you raise the temperature of a system, the molecules bounce around a lot more. They have more energy. When they bounce around more, they are more likely to collide. That fact means they are also more likely to combine. When you lower the temperature, the molecules are slower and collide less. That temperature drop lowers the rate of reaction. Concentration. If there is more of a substance in a system, there is a greater chance that molecules will collide and speed up the rate of the reaction. If there is less of something, there will be fewer collisions and the reaction will probably happen at a slower speed. Pressure. Pressure affects the rate of reaction, especially in gases. When you increase the pressure, the molecules have less space in which they can move. A greater density of molecules increases the number of collisions. When you decrease the pressure, molecules don't hit each other as often and the rate of reaction decreases. Characteristics of occurrence of chemical reactions. Chemical reactions provide several distinct observations that mark their occurrence. Some of the examples are given here in the form of simple activities. 1. Change of color. Activity. Change of color during chemical reaction. Take some lime water, calcium hydroxide in a container. It is colorless. Take a straw and blow in the lime water for a few minutes. The lime water will become cloudy white due to the formation of calcium carbonate by the carbon dioxide of your breath. 2. Change of state. Activity. Perform this activity under strict supervision of your teachers. Set up the apparatus to produce ammonia gas and store this in a gas jar. Introduce some hydrochloric acid vapors in this jar and observe the formation of white, feathery crystals of ammonium chloride on the sides of the jar. 3. Pungent smell. Activity. During heating, smell is given out. Take ammonium chloride in a test tube. Heat it. You will see fumes of gas which has pungent smell. This is ammonia gas. 4. Evolution of gas. Activity. During reaction, gas is evolved. Take calcium carbonate solution in a test tube. Add a few drops of dilute hydrochloric acid. You will see fumes of a gas. Take burning matchstick at the mouth of the test tube. The flame of the matchstick will extinguish. The gas is carbon dioxide, which does not support burning. 5. Formation of a precipitate. Activity. During chemical reaction, precipitate is formed. Take a solution of silver nitrate in water and add some sodium chloride, common salt, and heat gently. You will see a white precipitate of silver chloride. Evolution or release of heat. Activity. During chemical reaction, heat is also evolved. Take hydrochloric acid and add few drops of sodium hydroxide. During this reaction, heat is evolved and salt and water will be formed. The test tube becomes warm. Conditions necessary for chemical reaction to occur. Some of the necessary conditions for the occurrence of a chemical reaction are given below. Close contact. Close contact enhances the reactivity of reactants, which is necessary for the occurrence of a chemical reaction. For example, sodium reacts vigorously when comes in direct contact with cold water. 2Na plus 2H2O gives 2NaOH plus H2. Solution. In case of certain substances, chemical reaction occurs only in their solution form. For example, after adding a solution of silver nitrate to that of sodium chloride, silver chloride precipitate of white color is formed. NaCl aqueous plus AgNO3 aqueous gives AgCl plus NaNO3 aqueous. Heat. Occurrence of some chemical reactions are not possible without presence of heat. For example, on heating calcium carbonate decomposes in calcium oxide and carbon dioxide. CaCO3 heat gives CaO plus CO2. Sunlight. Some reactions occur in presence of sunlight only. These are called photochemical reactions. Most common example of this is photosynthesis reaction. 6CO2 plus 6H2O gives, on chlorophyll and sunlight, C6H12O6 plus 6O2. Electricity. In certain cases, electricity is basic need for occurrence of a chemical reaction. Such type of reactions are called electrochemical reactions. Electrolysis of water is an example of electrochemical reaction. 2H2O on electricity gives 2H2 plus O2. Pressure. Pressure is basic need for the occurrence of some chemical reactions. Formation of coal, gasoline in nature is because of high environmental pressure. Formation of ammonia is another common example of it. N2 plus 3H2 on heating at 450 degrees Celsius and 200 atmospheric pressure gives 2NH3. Catalyst. Catalyst is that substance which alters the rate of reaction without getting involved in it. In some reactions, addition of catalyst is important for its occurrence. For example, addition of oxygen and sulfur dioxide in presence of platinum or vanadium pentoxide as catalyst gives sulfur trioxide. 2SO2 plus O2 on platinum or vanadium pentoxide gives 2SO3. Types of chemical reactions. Chemical reactions are of many types, but we will study only 4 types of chemical reactions at present. They are combination reaction, decomposition reaction, displacement reaction, double decomposition reaction. Combination reaction. In a combination reaction, 2 or more reactants combine together to form a product. This kind of reaction is also known as synthesis reaction For example, hydrogen and oxygen combine together to form water. This reaction takes place in the presence of heat and sunlight. 2H2 plus O2 gives 2H2O. Similarly, hydrogen gas combines with chlorine gas to form hydrogen chloride gas. This reaction also takes place in the presence of heat and sunlight. H2 plus Cl2 gives 2HCl. Another example is when iron and sulfur are heated together, they form iron sulfide. Fe plus S gives FeS. When ignited in air, magnesium ribbon burns with a dazzling white flame to form a white powder of magnesium oxide. 2Mg plus O2 gives 2MgO. Decomposition reaction. In a decomposition reaction, one substance breaks down into two or more simple substances. Compounds generally decompose in the presence of heat, and therefore, these reactions may also be known as thermal decomposition reactions. Some examples of decomposition reactions are as follows. Potassium chlorate on heating decomposes to form potassium chloride and oxygen. 2KClO3 on heating gives 2KCl plus 3O2. Water is a compound which decomposes when electric current is passed through it. When electric current is passed through water mixed with a very small amount of an acid, then water decomposes to form hydrogen and oxygen. 2H2O gives 2H2 plus O2. Copper carbonate on heating decomposes to form copper oxide and carbon dioxide. CuCO3, green, on heating gives CuO, black, plus CO2. Lead tetraoxide decomposes to form lead monoxide and liberates oxygen gas on heating. 2Pb3O4, red, gives 6PbO, pale yellow, plus O2. Displacement reaction. In such reactions, one element displaces another from its compound and takes its place therein. For example, when placed in steam, a burning magnesium ribbon continues to burn, forming magnesium oxide and hydrogen. Mg plus H2O gives MgO plus H2. In this reaction, a magnesium atom displaces two hydrogen atoms and takes their place. When zinc granules are placed in dilute hydrochloric acid, zinc chloride is formed and hydrogen gas is evolved. Zn plus 2HCl gives ZnCl2 plus H2. This reaction occurs because zinc displaces hydrogen from hydrochloric acid. Take copper sulfate solution in a beaker. Add a clean iron nail to this solution. Gray iron nail is coated with reddish-brown copper. Fe plus CuSO4 gives FeSO4 plus Cu. Double decomposition reaction. In this reaction, two compounds take part, both are decomposed, and two new substances are formed by an exchange of radicals. These reactions are of the type AB plus CD gives AD plus CB. In these reactions, generally both the original compounds are soluble in water. one of the products formed is soluble and the other insoluble in water. For example, NaCl plus AgNO3 gives NaNO3 plus AgCl. Both the reactants, NaCl and AgNO3, are soluble in water. One of the products, NaNO3, is soluble in water and the other, AgCl, is insoluble in water. Chemical equation. We represent a chemical change with the help of a chemical equation. Thus, a chemical equation is a statement that describes a chemical change in terms of symbols and formulae. A chemical change is represented by a chemical equation. During a chemical change, existing substances undergo combination or decomposition and form new substances. We call those compounds with which we start reactants, and the new compounds that form are called products. In a chemical change, reactants form products. Reactants give products. In mathematics, you write 2 plus 3 is equal to 5 or 2 plus 3 is equal to 3 plus 2. Similarly, in chemistry, we indicate reactants on left-hand side and products on right-hand side. If there are two reactants, they are written with plus sign in between them on the left-hand side, followed by an arrow. Products are shown on the right-hand side of the arrow. H2 plus O2 gives H2O. This reaction shows chemical combination. However, if we decompose water, we get H2 and O2. Did you notice that there are two H and one O atom in water? That is, H2O gives H2 plus O2. Total there are 3 atoms on left-hand side, but 2 H and 2 O atoms on right-hand side. That is, 4 atoms. This is against rule. In a chemical change, atoms rearrange themselves. They cannot increase or decrease their number. Here comes the concept of balancing a chemical equation. Balanced equation. An equation in which the number of each atom of an element on reactant side is equal to the number of each atom of an element on product side is called a balanced equation. What should we know to balance an equation? We should know correct symbols of elements, exact valency of elements, correct formulae of compounds. Points to remember while writing an equation. Reactants are written on left-hand side. They are separated by plus sign. Product or products are written on right-hand side. They are also separated by plus sign. Between reactants and products, arrow sign is placed to show that reactants form products. In reversible reactions, we place a reversible arrow in place of a simple arrow. It indicates that reaction can proceed in either direction. Any gas evolved in a reaction is shown by an arrow pointing upwards, and the precipitate formed is shown by an arrow pointing downwards. While balancing an equation, we can only alter the number of molecules participating in the process, but cannot change the number of atoms of an element present in a molecule. For example, H2 plus O2 gives H2O can be balanced as 2H2 plus O2 gives 2H2O. We cannot write H4 plus O2 gives 2H2O. We cannot change the number of atoms per molecule denoted by subscript, as it will change the formula of the compound. Elements combine in a fixed ratio which we cannot alter. When we write 2NO, it means 2 into N and 2 into O, not just 2 into N. Similarly, when we write 2H2O, it means 2 into H2 is equal to 4H and 2 into O is equal to 2O. Let us try it out in CaNO3 whole twice. This formula contains 1 atom of Ca, calcium, 2 atoms of N, nitrogen, and 6 atoms of O, oxygen. Here, NO3 whole twice means N2 plus O3 twice. So, N is equal to 2 atoms and O is equal to 6 atoms. If we write 2CaNO3 whole twice, then number of all atoms will be doubled.